Hello students, in this video let us discuss the named reactions as a continuous to the previous video. So in this video let us discuss the KOLBE'S reaction, REIMER reaction, soda-lime decarboxylation, KOLBE'S electrolytic decarboxylation, HVZ reaction, reactions involving amines, that is AMMONOLYSIS, GABRIEL THALIMIDE synthesis, HOFFMANN bromide reaction, reactions involving alkyl halides and aryl halides, that is WURTZ reaction, FITTIG reaction, WURTZ-FITTIG reaction, and reactions involving ethers, that is Williamson's synthesis. Please subscribe to my channel, like, share and comment my videos.
Now let us discuss KOLBE'S reaction. Phenol on treatment with dilute alkali at 400 Kelvin and 4 to 7 atmospheric pressures to give 2-hydroxy sodium benzoate, which on treatment with dilute acid to form salicylic acid. So here this is phenol with sodium hydroxide. Therefore we get, what is this? Sodium phenoxide. This is at 400 Kelvin, 4 to 7 atmospheric pressures, and of course CO2, we get OH, COONJ. This is 2-hydroxy sodium benzoate, 2-hydroxy sodium benzoate. So this on treatment with dilute acid, therefore we get this is 2-hydroxy benzoic acid. IUPAC name, or otherwise common name is salicylic acid. Salicylic acid is the starting material for the preparation of substances like aspirin. Salicylic acid starting material for the manufacture of aspirin. Aspirin is analgesic. Analgesic means pain reliever. So salicylic acid is the starting material for the manufacture of aspirin and analgesic. So here this is salicylic acid in the presence of CH3CO, CH3CO. What is this substance? Acetic anhydride. Acetic anhydride. This in the presence of concentrated sulfuric acid and of course high temperature. Therefore we get OCOCH3. This is COCH3. This is referred as 2-acetoxy benzoic acid. 2-acetoxy benzoic acid or acetyl salicylic acid or acetyl salicylic acid. Plus of course here CH3COOH, and this substance is known as aspirin. Aspirin means a pain reliever, analgesic. Suppose if salicylic acid is treated with phenol C6H5OH in the presence of phosphoryl chloride, in the presence of phosphoryl chloride, and of course reflux conditions. Therefore, what do we get? This is OH, COO, C6H5. This is phenyl salicylate. It is known as salol. Salol is an intestinal antiseptic. So here salicylic acid is treated with phenol in the presence of phosphoryl chloride, and phosphoryl chloride is POCl3. Reflux conditions, we get phenyl salicylate. Phenyl salicylate is used as an intestinal antiseptic, which is commonly known as salol. So REIMER-TIEMANN reaction. In REIMER-TIEMANN reaction, phenol on treatment with chloroform in the presence of aqueous alkali at 343 Kelvin and form orthohydroxybenzaldehyde as a major product. So here this is phenol in the presence of CHCl3 343 Kelvin and aqueous NaOH CHCl2. This is an intermediate substance. This is the name of this substance is 2-dichloromethyl phenoxide. This on treatment with again sodium hydroxide, ONaCHO. This results in OH. This is CHO. This is 2-hydroxybenzaldehyde. This is also referred as salicylaldehyde. This is the major product. Plus another substance also forms. This is OH. This is CHO. This is a para-hydroxy or 4-hydroxybenzaldehyde. This is a minor substance. In the reactions, that is KOLBE'S reaction and REIMER-TIEMANN reaction, the starting material is phenol and the products are orthohydroxy substances, orthohydroxy benzoic acid and orthohydroxybenzaldehyde. Now let us discuss the decarboxylation reaction. Decarboxylation reactions. Decarboxylation means carboxy means carbon dioxide. Decarboxylation means removal of carbon dioxide from the substance. So here the first one is soda lime decarboxylation. What is soda lime decarboxylation? NaOH plus CaO. So soda-lime decarboxylation means acid salt is treated with acid salt of carboxylic acid treated with soda lime to get an alkane with one carbon less than the parent salt. So the reaction here is CH3COONA plus NaOH in the presence of calcium oxide and of course temperature. So this is removed. This is removed as a Na2CO3. Sodium carbonate is removed. Therefore, we get CH4 methane. CH4 methane. See this reaction. In this acid salt, 2 carbon atoms are there, whereas here only 1 carbon atom is there. Now let us take one more example. CH3CH2COONA plus NaOH in the presence of CaO. Of course, sodium carbonate is removed. So here sodium carbonate is removed. Therefore, we get CH3. This is ethane plus sodium carbonate. So here the resulting alkane has 2 carbon atoms, whereas parent acid salt has 3 carbon atoms. Therefore, these reactions are used to descending the series. Descending the series means the product substance has 1 carbon less than the parent acid salt. So this reaction is referred to as descending the series. So in soda-lime decarboxylation, as carbon dioxide is removed. So carbon dioxide is removed in the form of sodium carbonate. Therefore, this is referred as a soda-lime decarboxylation. Next reaction is KOLBE'S electrolytic decarboxylation. So here an acid salt is subjected to electrolysis. Therefore, we get alkane. Carbon dioxide releases. Since carbon dioxide releases are removed, it is referred as decarboxylation. And of course, this decarboxylation is carried out by electrolytic process. So here CH3COOK. What is this? Potassium acetate. Potassium acetate aqueous. This aqueous potassium acetate it dissociates into CH3COO minus. This is acetate ion plus K plus. Right. Therefore, the reaction at anode. Anode means plus. So positively charged electrode attracts the anions. So here acetate ions reach anode, and of course here gives CH3. This is a methyl free radical plus CO2 plus 2 electrons are released. This is methyl free radical. We know that free radicals are highly reactive. Therefore, 2 such methyl free radicals combine, we get ethane. CH3 ethane. This is ethane. So at anode we get ethane gas and of course carbon dioxide gas. 2 are released at anode. On the other hand, reaction at cathode. Reaction at cathode means minus. So here H2O, water, 2 molecules of water take 2 electrons. So 2 electrons are released at anode and 2 electrons are taken at cathode. Therefore, we get this is H2 gas plus 2OH minus. So finally in the electrolytic cell. In the electrolytic cell, what is left? K plus is left and OH minus is left. Therefore, this is nothing but KOH. So initially we took potassium acetate and finally we get KOH, potassium hydroxide. So this is a Kolbe's electrolytic decarboxylation. So in both the decarboxylation processes, carbon dioxide is removed. Now let us discuss the reactions involving amines. Reactions involving amines. What is the amine group? NH2. That means the amine may be product, amine may be reactant. So the first reaction is ammonolysis. Ammonolysis. In ammonolysis, alkyl halides are benzyl halides. Benzyl halides are treated with ethanolic solution of ammonia. Ethanolic solution of ammonia at 373 Kelvin. At 373 Kelvin to form amines. Now let us see one reaction. RX, this is alkyl halide, plus NH3 ammonia. So this lone pair comes and attacks here. Therefore we get, this is 373 Kelvin and we get RNH3 plus and of course X minus. So here what happens? HX is removed. HX is removed. Therefore we get RNH2. This is a primary amine. So this primary amine is treated with excess of RX. Therefore we get RNH and of course RNH. This is secondary amine. This on treatment with still excess of RX, that is alkyl halide, and we get R3N. This is tertiary amine. This on treatment with still excess of RX, therefore we get R4N plus X minus. This is quaternary alkyl halide. So the condition here is, in this reaction, if alkyl halide is in excess, if alkyl halide is in excess, what do we get? Quaternary salt is the major product, and of course we get the mixture of different amines. So quaternary salt is major product. So here we do not get primary amine alone. If ammonia is in excess, then primary amine is the major product. So these are the conditions for this ammonolysis. But anyhow, this reaction cannot be used for preparing primary amines alone, because we get the mixture of different amines and major product is a quaternary alkyl halide salt, and separation becomes very difficult. Now let us discuss the second reaction in reactions involving amines, that is Gabriel thalamide synthesis. So here CO, this is thalamide. This thalamide is treated with potassium hydroxide, KOH, water is removed, and of course at high temperature we get CONK. This is potassium thalamide. Potassium thalamide. This potassium thalamide is treated with RX, alkyl halide. So what do we get here? NR. This is N-alkyl thalamide. N-alkyl thalamide. This N-alkyl thalamide is treated with alcoholic sodium hydroxide, alcoholic alkali. Therefore, what do we get here? This is N-alkyl thalamide is treated with aqueous NaOH. Therefore, we get CO. This is COONA. This is COONA. Sodium thalate. This is sodium thalate. So our product here is RNH2. This is primary amine. So here in this Gabriel thalamide synthesis we get only primary amine. Therefore this is the best method for the preparation of primary amines. Now here secondary and tertiary amines. Secondary and tertiary amines cannot be prepared. Secondary and tertiary amines cannot be prepared. Not only that, aniline also. Aniline means aryl amine. So this is aniline. Aniline also cannot be prepared. So this is for a Gabriel thalamide synthesis in which only primary amines are prepared. Now in this another reaction is Hoffmann bromamide reaction. So in this Hoffmann bromamide reaction, primary amide, this is amide. Amide is treated with bromine. Amide is treated with bromine in the presence of potassium hydroxide. We get RNH2 plus KBr plus K2CO3. Therefore here it is 4 plus 2H2O. So primary amide is treated with bromine and bromine in the presence of potassium hydroxide. We get primary amide. So here this is CH3CO NH2. What is this? Acetamide plus bromine plus 4KOH we get, and of course here it is 343K. We get CH3NH2 methylamine plus potassium bromide plus potassium carbonate plus. So this is a Hoffmann bromamide reaction. So let us take one more reaction. This is what is this substance? Benzamide. Benzamide is treated with bromine in the presence of potassium hydroxide. We get aniline. This is aniline plus potassium bromide plus potassium carbonate plus water. So here also in a Hoffmann bromamide reaction also we get primary amines. So these are these three reactions, that is ammonolysis, Gabriel thalamide synthesis and Hoffmann bromamide reaction. In all these reactions amine is the product. Now let us see HVZ reaction. HVZ means Hell-Wohlhold-Zelinsky reaction. Hell-Wohlhold-Zelinsky reaction. In this reaction, halogen is introduced. Halogen is introduced at alpha carbon. alpha carbon of carboxylic acid. Halogen is introduced at alpha carbon of acid. So here this is acetic acid. Acetic acid is treated with chlorine in the presence of red phosphorus. Chlorine in the presence of red phosphorus, we get CH2Cl. This is COOH. This is 2-chloroacetic acid or alpha chloroacetic acid. This on treatment with further red phosphorus, this we get CHCl. This is COOH. This is 2,2-dichloroethanoic acid. Ethanoic acid or acetic acid. So this on treatment with in the next step chlorine in the presence of red phosphorus, we get CCl3COOH. This is a trichloroacetic acid. Trichloroacetic acid. This can be named as a 2,2-trichloroacetic acid also. Or 2,2 may not necessary because there is only one carbon atom on carboxylic acid. So it is a trichloroacetic acid. Suppose if we take CH3CH2COOH in the presence of chlorine and red phosphorus, we get CH3CHClCOOH. So what is the name of this substance? Name of this substance is 2-chloro-propanoic acid. Now, if it is treated with bromine and red phosphorus, we get CH3CHBr COOH. This is 2-bromo-propanoic acid. 2-bromo-propanoic acid. So this is a HVZ reaction. In a HVZ reaction, that is Helmholtz and Zielinski reaction, halogen atom is introduced at alpha carbon of carboxylic acid. Now let us discuss the reactions involving alkyl halides and aryl halides. In this class of reactions, the first one is WURTZ reaction. Alkyl halide. Alkyl halides are treated with sodium in the presence of a dry ether. In the presence of dry ether, to get alkane with double the number of carbon atoms. Alkane with double the number of carbon atoms. For example, CH3Br methyl bromide plus sodium plus methyl bromide. That means two molecules of methyl bromide react with two atoms of sodium in the presence of dry ether. Therefore, sodium bromide is removed, minus 2NaBr, and of course we get ethane. So in a parent alkyl halide, how many carbon atoms are there? 1. Whereas in the product alkane, 2 carbon atoms are. Therefore, this is double the number of carbon atoms in the parent substance. Similarly, if you take C2H5Br plus 2 sodium plus Br C2H5 in the presence of dry ether, therefore sodium bromide is removed and we get C2H5. What is this substance? Butane. So we took ethyl bromide, we got butane. So thus we get the alkane with double the number of carbon atoms. Now let us take an example with two different alkanes. For example, CH3Br plus 2Na plus ethyl bromide C2H5. What do we get here in the presence of dry ether? What are the substances obtained? So we get CH3C2H5. This is propane. Not only this, there is a possibility of reacting two methyl bromide molecules also. So we get 2NaBr, we get CH3CH3 ethane, and of course here 2Na, we get C2H5. So this is ethane, this is butane. So the question may be asked in this manner: what are the products obtained in this reaction? So the answers may be given as one is C2H6, B, C3H7, D, this is C, C4H10, this is C3H8, C4H10D, all these. So what is the answer? All these substances are formed in this reaction, that is WURTZ reaction. Now let us see another substance, that is FITTIG reaction. FITTIG reaction is also similar to WURTZ reaction, but only the change is in WURTZ reaction we used alkyl halide, whereas in FITTIG reaction we take aryl halides. So aryl halides. So here this is bromobenzene plus 2Na plus Br. So in the presence of dry ether minus 2NaBr, we get, what is this substance? Biphenyl. This substance is biphenyl. So in FITTIG reaction, the product is biphenyl. Now let us see the cross reaction, that is WURTZ reaction as well as FITTIG reaction, both will take place. Therefore this is referred as a WURTZ FITTIG reaction. So in WURTZ FITTIG reaction, one molecule is aryl halide, another molecule is alkyl halide. So the reaction now is WURTZ FITTIG reaction. This is CH3Br plus 2Na plus Br in the presence of dry ether minus 2NaBr. Therefore what do we get? Here also more than one compound is formed, just like in the previous example as we discussed. Therefore the main product is, this is methylbenzene toluene or toluene plus, what are the other options? Ethane, CH3CH3. What is the other option? Biphenyl. So these are the, so this is a WURTZ FITTIG reaction. In WURTZ FITTIG reaction we use one alkyl halide and one aryl halide. Therefore we get different substances, 3 different substances, and of course this is WURTZ FITTIG reaction. So in these reactions involving alkyl halides and aryl halides, we have 3 different reactions: WURTZ reaction, FITTIG reaction, and WURTZ FITTIG reaction. Next reaction is Williamson's synthesis. In this Williamson's synthesis, ethers are prepared. So in Williamson's synthesis, alkyl halides are treated with the sodium or potassium salt or phenoxide or alkoxide to form ethers. So here this is RX plus NaOR dash. So what do we get here? Sodium halide is removed and we get ROR dash. This is ether. Now let us take different examples. CH3 methyl bromide plus sodium methoxide. This is sodium methoxide. We get CH3OCH3. This is a dimethyl ether. Our IUPAC name is methoxymethane. methoxymethane. This is symmetrical methane, symmetrical ether. Symmetrical ether. Symmetrical ether means with respect to ethyl oxygen, both the alkyl groups are same, therefore it is symmetrical ether. Then if we take CH3Br plus, we get CH3OC2H5. What is this substance? This substance is methoxyethane. This is unsymmetrical ether. Unsymmetrical ether. So with respect to ethyl oxygen, we get two different alkyl groups, therefore it is unsymmetrical ether. So this is a secondary alkoxide, secondary sodium alkoxide plus, therefore we get CH3CCH3OCH. So what is the name of this substance? 2-methoxypropane. 2-methoxypropane. Suppose if we reverse the substances means this is CH3CH3. This is secondary alkyl halide plus NaOCH3. Instead of forming the ether here, alkene is formed. So this is CH3, CH double bond CH2. So instead of forming ether, elimination takes place. Elimination takes place. Right. Let us see one more example in the same manner. CH3C ONA. This is a tertiary alkoxide plus bromine CH3. Therefore we get ether here. This is CH3 CCH3 CH3 OCH3. What is this substance? 2-methoxy, 2-methyl. This is long chain. 2-methoxy. This is 2-methoxy. This is 2-methyl. 2-methyl propane. 2-methyl propane. If we reverse the substances, that is CH3, instead of sodium alkoxide, tertiary sodium alkoxide, if we take tertiary alkyl halide, this is bromine plus NaOCH3. So what happens here? Elimination takes place instead of forming the ether. Therefore we get CH3C, CH3 double bond CH2. This is 2-methyl propene. 2-methyl propene. 2-methyl propene. Now let us see the reaction involving with the phenoxide. This is CH3Br plus NaOC6H5. We get, this is removed as sodium bromide. This is OCH3. This is methoxybenzene. This is methoxybenzene. If you take C2H5Br plus Na sodium phenoxide C6, we get OC2H5. This is ethoxybenzene. Suppose if we reverse the substances, that means let us take C2H5OBr plus, this is aryl halide. This is Na aryl halide. If you take aryl halide and sodium methoxide, then reaction does not take place. No reaction. Why it is so? Aryl halides are least reactive towards nucleophilic substitution reaction. Least reactive towards nucleophilic substitution reactions. So, in all these, we discussed Williamson's synthesis, in which the ethers are prepared.